Okay, so here's how I want you to solve these equations. So basically we're going to do this with our calculators for now. For this section I'm using intersect. So go ahead and type into y1 cosine 2x minus pi over 3. So hit y equals, clear out what you have, alright, and then type in cosine of 2x minus pi over 3, and then go ahead and hit zoom 7 for zoom trig. Now pay attention to this because we want to solve our equation for 0 to 2 pi. So that's what we want to make our window in the x direction. We want to go from 0 to, let's just say 6.5, right? Because 2 pi is 6.28-ish. So hit window, change your x min to 0 and your x max to 6.5. And then, because we changed our window, hit graph. Okay, so now what we want to do is we want to figure out part D. We want to solve for when this equation is 1. So go back into y equals and make y2 1 and then hit graph. And you'll notice here that your graphs intersect in two places in your window, right? And if you think about that, if you're trying to solve cosine of theta equals 1, there's only one place that cosine is 1, right? That's at 0, which is the same thing as 2 pi, right? But only one of them would occur in the first cycle, because usually what we write is 0 less than or equal to theta less than 2 pi. But notice here that we have changed the period, right? So our period is going twice as fast. That's what our B is telling us. So we now have more than one solution, okay? So let's find the first one first, and we'll do second and trace and hit number 5 for intersect. And first curve, enter. Second curve, enter. I want to find, let's see, this one on the left first, and I hit enter. And it tells me that x is 0.524. So for D, x equals 0.524, or I now need to find the second one. So go through it again and hit second and trace, number 5, and then enter and guess. And then my answer is what, 3.665. Okay, so for part D I have two solutions. So the biggest thing for now is that, yeah, we haven't quite figured out how to solve this algebraically yet, right? Because basically what's happened, I have a cosine of some angle is 1. Well, I know that in the first, in between 0 and 2 pi, cosine of theta is 1 at exactly one place, right? And actually, I just want to be clear here, this is probably a typo, but we want to get rid of these. It actually doesn't matter for the sake of this problem, because we can look at the picture and see that this is intersecting our graphs twice. But if we're just looking at the first revolution, cosine is 1 in only one place. Okay, but since we've made our period twice as fast, right, we have two periods that appear in our window, or between 0 and 2 pi, so therefore we have two solutions. Okay, so that's the one thing that we need to be careful of going forward, is that if we change the period, we could have more, or if we, in the case where we actually stretch out the period, we have fewer solutions. So use your graph for now to figure out what your solutions to parts D and E are. So for E, basically you go in and hit Y2 and change the second Y2 to 0. Okay? And that's about it for now.